Hello everybody and welcome back. So in this next lesson, we're going to be talking about all the extra features that come with an attribute wrangle, everything under this bindings tab, which kind of all relates to keeping our data clean and avoiding overriding things that may already be on the geometry coming in. So we're just kind of controlling how we're binding data out and where we're accessing certain information from, like our evaluation node path, the attribute to match. So we're just going to just basically be discussing everything under this tab and how we can use this. And in particular, this mostly relates to like when we're working with a digital asset, essentially. So in this case, we can pretend that this node, I'll even give it a different color, we can pretend that this is a digital asset, okay? I haven't actually published this, but it doesn't really matter. The principle is the same. So at the top here, I've got just some incoming geometry. So we just got some actual geometry, a relevant attribute that I will want to access. So, maybe you would expect our users like input geometry to have an actual normal, and then some attribute on there which they have on their geometry that we kind of would maybe want to be overriding. But we don't want to actually overwrite it and lose the value that they've set, but for our own calculation purposes, we need to use this attribute, okay? Because we cannot know, when you create a digital asset, you cannot know what your users are going to plug in there. I mean, obviously, you can try and explain what type they should plug in, what piece of geometry, but they could have attributes on there that you're already using, and it becomes most difficult. First of all, you don't want to overwrite the attribute. You don't want, because it'll be a bad digital asset if, I have a foo attribute on here. I plug this into your digital asset, and at the end, I lose my foo attribute. Very, very frustrating. But also, if I've bound this out as a float, but you're using foo as a vector, then you're not going to be able to access your information correctly because it's already bound as a foo. So then the whole tool will break. Okay, so we need to be very careful about how we handle all of these different attributes. So let's jump inside here. So to sort of simulate how this would be a digital asset, I've had this plugged in and I've got an object merge just reading in whatever is plugged into the first input. So then we would do the work that we want to inside of this digital asset and then, output a result. And obviously I'm doing it on geometry level, but you could do the same thing at SOP level, so we would just contain it within a subnet. All right. So on this wrangle, I've got a couple of things. So I've created a variable called seed, and I'm just referencing a channel, a float channel for seed, and I'm just adding 1 just because if you ever multiply by a seed, you don't want to multiply by 0. Okay. And then I'm writing out just a couple of attributes, and I'm not doing anything fancy, just creating a random based on that seed. So foo is equal to rand of ptnum. Then I've got test, which is equal to foo, and temp, which is equal to test. So in other words, these 3 should end up with the same. The reason I'm doing this is just because I'm going to show you just now different examples of how we're going to bind these out and the different results. So I kind of needed 3 attributes to show you what's going to happen. And then I'm also creating a point group using the set point group function, okay, with an if statement. So the first 20 points are being set into this group, and then this is an alternate method. We've mentioned making groups before, but I actually haven't mentioned this method before of creating a group, which is that you feed it an integer attribute and you just have group underscore and then the name of the group, and it will actually turn this into a group. Okay, so without having to do the set point group, you don't get the same functionality here as in being able to feed it different point numbers that are not your own, or to choose the mode, so how to either add or set or subtract or something like that. So this has a lot more functionality, but if you're just wanting to do something simple and just create a group, then you can do it exactly like this. You just have an integer, so it'll be 0 or 1 on each point, and then you feed it its group underscore and then the name of the group, and you'll end up with that in here. So mine was called group 2, and this is exactly the group membership is defined by this integer. Okay, so we've got all of that set up, right? Oh, and here's my seed channel. So now let's jump over to the bindings tab. So the first thing we have here is, this is basically talking about the binding of your actual attributes, so not your groups. There's a separate section for groups. And this first tick box is essentially just controlling whether attributes actually get bound out by using our f@ syntax, right? Now you see when I switch that off, we've got foo, but we don't have test or temp. And the reason for this is because foo already existed. So there's foo, which means we can write to foo, okay? But you see here, it already was 5. So now when I say don't bind out, it's not going to bind to foo, although foo will still exist because it already did. And test and temp have not been written out at all, okay? So basically it's closed the gates, and this entire wrangle, we can perform operations inside of here, but we're writing nothing out in terms of attributes. Now, the other things you can do is you can kind of create your own custom binding over here. Now, what this allows us to do is, no matter what we've called it in our code, okay, so foo, we can take foo. Now, just be careful which way around this is, because you kind of used to going, okay, well, if I want to rename foo to something, this will not work. Just read carefully. The attribute name is the output that we want, and then this is the vex parameter, so actually how it is in our code. So it would be the other way around. Okay, so if we write it like this, okay, it's basically saying, look in our vex code, and every time that we try to bind out foo, instead bind out to the word something. Okay, so now you'll see I still have my foo attribute, which is untouched from that 5 that it originally was, but then I also have this something attribute, which is from foo. Okay, now I know you're asking, okay, so well, why not just call it something in here? I mean, that would be easy, okay, and that would work, right? But sometimes you've got a lot of code, and within the code as well, the names that you're using make sense, right? You can't then go, it's an absolute pain to have to go through your code and change, from foo to something else, or just to account for whatever attributes may or may not already be coming in, okay? So using this binding allows you to just kind of leave it as is, or use internal names that actually make sense within the code. So maybe even like something like a grad is a word that's often used for your gradient. So maybe you're wanting to create a gradient in here, but then it would be a pain to go and replace the word grad, and have to also, the code wouldn't be easily readable without that word in there. And yet you can't bind out grad. You need it to be something else. Well, this is a way to then do it. Okay, so then you kind of post code, you're actually just changing the binding. And one really good feature of this is to actually allow your user to choose the name of the attribute that is output. So I've created a string parameter on the top here, and inside, if I reference that, so now I'm allowing the user, even though they're not in control of the code, but they can choose what the binding is. And there we go. They get to choose that name, and now the attribute written out is called whatever, but our code still remains exactly the same. Okay. Right. So we've got that, and then I want to show you here the group binding. So this works similar as well. If we untick this, it will not allow us to write out groups using this group underscore syntax. Now you'll see that with that ticked off, we still have something over here, but this says group underscore group 2 as an attribute name. This is not a group. If I middle click, you'll see that the number of point groups I have is just 1, and it's my point group. My group. Okay, which I'm creating here using this set point group function. So it's important to note that this still works. No matter whether this is on or off, this is forcing like the creation of a group. Whereas this quick syntax using group underscore to create a group is linked with this. If we tick it off, this will be an attribute. If we tick it on, it will turn that into a group. Okay. And then something else you can do in here is you reference a Vex parameter and then you give it a group name. Now we can use this in a similar way to what we just did as well. But what's really cool is we can actually take something like test over here. Okay. And instead of it being an attribute, we decide that we actually want this as a group. So we can call our group something, group 1, well, something like that. I don't know, whatever. And then our Vex parameter would be test. So we say test. And over here we have group 1, and you see that its membership is exactly the same as, our random. So it's based on foo originally, and if we have a look at foo, which is actually now called whatever, you'll see that whenever the value is below 0.5, the group membership here will be 0. Okay, and then as soon as it goes above 0.5, then it's 1. Okay, because that's just because test is a float and it's being automatically rounded. But we may, I would suggest that you round it yourself, because you can choose whether you want to floor or ceiling or round to the nearest integer. You're at least in control of it. Okay, but you'll see here we were able to then just create a group out of an attribute. Okay, so there's that. Then the next step as well is this evaluation node path. Is really quite useful, especially for creating digital assets, because when you're deving, you create these channel references directly on here, and you sort of, you can use this to create spare parameters, and then, you've got control over your seed. But later on, when you turn this into a digital asset, you then have to go and promote this to the top level over here and link it. So then you have to go here, copy, inside, paste, copy, relative reference. And that doesn't seem too bad, but when you have 50 parameters on 20 different wrangles, it's a lot. Okay. So instead of having to link them all, what we can do, this path over here controls where our channel references begin to search from. So when we say CHF and then we just give the name, that just means that it's on ourself. Whereas we could give it a path. So we could go ... and then seed. And then we would be referencing the seed that is on here. Okay, because we're saying go up one level and then look for something called seed. So in other words, on our grid 1, look for seed. Okay, but you don't want to have to now run through your code again and type ... next to every channel reference just to force it to go up one level. Okay, so instead here we just choose in here to enter ... and this will change the path to where it's referencing. So now it detaches from this. This will no longer change anything. Although if we did want to dive inside and fix something, we could go and put this back to star and dot, and then work here just to do some fixing. But you'll see just by changing that to ... now our seed has been redirected to start looking from this point onwards. Okay, and this can be super useful just to take all of your, like when you've got 50 different parameters, just change this one ... and suddenly all of them are referencing this and looking for parameters with the same name. But just be careful, they do have to be named the same. Okay, and if you have multiple wrangles that each have a seed and they're all looking at the top for something called seed, then they're all going to be referencing the same seed. That may be what you want, that may be the desired result. But if it's not, then be careful. You do need to give a unique name if you're wanting another wrangle to have a seed, but each of them should be a separate seed. Then you'd have to say like seed 1 or something like that. Okay. So then we're talking about here the export parameters. So this will just choose which parameters to export based on this mask. Okay, so if we take this away, you'll see that nothing gets written out. Okay, now again, I'll point out that the my group still works, because this function is like very manually going in and setting this group. Okay, so this I wanted to leave in here to show you how forcible this is. Okay, so any functions we run that go and set, I mean, you could set attributes using the set point attribute function, and then those would also be set because it's doing a separate call to the geo handle, and it's writing this group in. Okay, but in terms of all of these automatic bindings of and exporting of parameters, we're in control of it here. Okay, so with nothing in there, it's going to export nothing, even if we've got all of our things ticked on correctly here and binding out. And what this does is it lets us also, control what we're writing out. If we're doing a lot of work in here, but then maybe we want our user to have control over what gets written out, then we can provide them access to this. So then we don't actually need any parameters written out, but we do the binding in our code, and then make sure that they have access to this so that they can decide if they want, foo. And you'll see here, if I reference foo, it's actually writing out whatever, because this happens before the binding, the renaming of the binding over here. So I'm looking inside my code and saying, yes, export foo. And then it's saying, okay, but foo is actually equal to whatever. Right. So you can use wildcards in here. So you could say, well, export everything except foo, and then it will not write out our whatever attribute. Okay. And often I use this with temporary attributes, where I'll use an underscore in front of every attribute that is actually temporary. So I would do something like an underscore star, underscore test and underscore temp, which will sort of denote that these are my temporary attributes. Okay, and it'll write them out that way. But then in your bindings here, you say everything except underscore star. Okay, and then it will not write out any of your temp attributes which have underscores in front of them. Okay, or it can be a way for you to sort of very quickly and easily disable the export of an attribute, but without altering, because you see, if I disable this entire thing, then test doesn't get written, well, temp doesn't get written correctly, because test is coming from foo, and foo is then coming from the 5 that it originally was. So we can't disable the entire line, but we just want to not export it. So then we put an underscore, and because we have this set up here, then it will not write it out. Okay. So lots of really useful little tricks that we can do to control what leaves this wrangle. Then obviously we've spoken already about this attribute to match. That's just if we're using the at op input syntax. So over here I've got an example of that, where we said the at op input 1 underscore p is basically fetching the point position from the second input because of the 1. And if it doesn't match point numbers, and if it finds ID, then it will use ID. But if you can change here what it uses as a matching attribute, so then it'll look on our input geometry, so 0 and on 1 for matching values, and we'll then copy those attributes accordingly. Okay, and then at the end here as well, we also have this output selection group. Okay, so that will just be we can feed it a group or list of points that would be sort of selected, and a lot of sort of modeling nodes have a way of referencing the previous selection group. So then without creating a permanent group out of it, you can kind of reference whatever this wrangle works with and read it in a modeling node, and maybe peek those points or something like that. So here, because we created our my group, we can just maybe use my group in here, and then this will have these 20 sorry, let me just show you here. We've got the first 20 points are being put in that group. So you'll see that they come through selected, and then we'll be able to reference that in other nodes that will say like your group selection. Okay, so that's basically it for the features here. Oh, sorry, I skipped over this. So there's an update normals if displaced. That will just mean that whenever it displaces your point positions, it will actually update your normals. Okay, and then compute results in place is if you have nothing that references a geo handle. So if we didn't have this feature or this particular function. Okay, so if you do end up with some code that just is working internally and doing absolutely nothing by referencing the first input, then you can tick this on, and then the code will actually run a little bit quicker because it will only create one geometry handle copy. Okay, so that's just a cool feature, but I don't know, I very rarely use this because the amount of times where you want to reference things on the outside with a wrangle is so numerous that this almost seems redundant. Okay. Now, I just wanted to talk quickly about one more way of keeping things clean. And you should use it in combination with what we just learned as well. So this is not a replacement, but rather just in addition, especially when it comes to digital assets. And in particular, see, when we create digital assets like at the studio, it's generally for just one project. It's being used by very specific people, or sometimes we're just creating a digital asset to reuse ourselves, but like just for convenience. So there things are a lot more under control. But when you write out a digital asset that you plan on publishing, maybe putting it online, letting people use it, then you're talking about hundreds or thousands of people that are downloading this tool, and that in their scene it just starts breaking because you haven't accounted for how they're going to use it. Okay, so here I have the same object merge. I just wanted to sort of work in a separate stream to not confuse the two. So we bring in our geometry. Now, what I often do when creating a digital asset is I will work in a separate stream and then use a wrangle to copy across or blend over into everything that I want to have happened from this stream, but dropping all of the temporary attributes that were created along the way that I didn't actually need. Okay. Now, you can't just do that by working in one stream, but then just putting down an attribute delete, because remember, you may want to preserve what your user has coming in. You can't just go and delete foo. So I'll say, delete star, because I don't want any incoming attributes. Because at the end, then you've lost your normals, you've lost your foo, and the user is going to be really frustrated that every time they use your tool, they lose all their attributes. So instead, what I do is I work in a separate stream. In the separate stream, I will delete everything except for the things that I know that I need. So maybe my code relies on normals. Okay. So I know I need normals, so I'm going to not delete that, but I'm going to delete everything else. Okay. Then I run my code, and I can even store temporary attributes because, like I've shown you before, and we will be talking about this more in the future as well, is sometimes you have to have multiple wrangle nodes. You process one wrangle, and then you go into the next wrangle, and then, so you have to pass. Sometimes you cannot just create a variable. You need to write out an actual, bind out an attribute because you need it in another wrangle, maybe running over primitives or points, so you need to promote it or do something else. Or there's a certain feature that isn't in Vex, so you need to run it through another SOP and then back into another wrangle to finish off the code. Okay, so that's going to happen often. Now, like I've already mentioned, my technique of just having an underscore here to denote temporary attributes. So I would still recommend using this, but whether you use this or not, there are going to be temporary attributes written, okay, that you will then want to maybe clean up and delete. So it doesn't matter even if we did use just foo here, because it's our foo, not their foo, right? We've deleted it, cleared it up, using it ourselves, and then at the end, so in here I'm just offsetting my point positions along the normals, and I'm also creating a foo attribute by random by ptnum, and then in here I'm creating color. Okay, so you may want to reference those attributes, but then here we just do that op input one copy of all the attributes that we actually want to preserve from this stream. So the whole result of this was to create color and point position. So that's the only things that I copy across. Okay, that way any temporary attributes were not overwriting what the user had. They were not competing with different bindings. So if foo was a vector and I'm expecting to create a float foo, then there would be problems. We don't have any of that because we've deleted it properly. Okay, then worked with it all and then left those attributes behind and only copied across what we need. This is a very, very clean way of working. Okay, now on here you may find that you still want to actually be transferring certain attributes. Something like point position and color and normals are reserved keywords. So those are attributes that we want to overwrite. If you want to change the position of the points, you have to overwrite P. You can't store it as a different attribute. You need to overwrite P. So that's fine. But if you're creating any other attributes, even something where you think the user won't need that attribute name, okay, you should still allow them to change how it's bound out. Okay, so again, we have our foo being written, we're grabbing it from the second stream, but then we're allowing them to choose whatever it should be. Okay, even if this is just one of the last tabs, like a miscellaneous tab in your tool, and kind of just allows the user to change the names of the parameters that are coming out only if they need to, and then you would have this set up already in the fop. Okay, foo. So you would have it set up by default to sort of write it out how you would like it to be written out. But if they have a problem and contact you and say, oh, the tool's not working, it's overriding my foo, or it's doing this weird thing, then you just say, no, just, control over here and, just call it, something else. And then your attributes will be preserved. Okay. So it's not like it needs to be a main feature of your tool, but to not include it means that you're sort of asking for trouble. Depending on what you're writing out. Obviously the ideal is that you're not writing out any attributes like this, but actually just key attributes like point position and color. But that's not always possible. Sometimes you're wanting to write out an attribute for your user. Okay. All right. So that wraps it up. And I hope this has helped. I know this is not always this is not super flashy and fun, but this type of stuff is really good practice and will help you with your coding, especially if you're planning on creating really cool tools. You want them to be robust. You want it to, no matter what your users are doing and whatever they have, that it just works nicely. And believe me, when you write giant chunks of code, you're going to be really grateful for knowing that you can change the binding name without having to run through the code and rename every single attribute reference. Okay, right. So I hope you guys enjoyed that, and I will see you in the next lesson.